Okay, so we're going to finish up 5.3 part 2. And we're going to look at 3 things that you can do with writing complex numbers in trig form. They're things that we already know how to do, but we can do them a lot easier in trig form than the way we already know how to do it. So the polar form, or I say polar or trig form, it means the same thing. So don't be confused whichever way you say it. The polar form of a complex number gives us a quick way to do multiplication, division, and exponents. We are going to look at exponents as well. So what I'm going to do first is I'm going to review doing something the way we already know how to do it, and then I'm going to do it a lot faster. And maybe what I'll do is if I didn't close it, I'll go back. I'll close the homework. All right, well, I'll just make one up again. Maybe I can remember the one we just did. Okay, the one that we just went over in the homework, was it, not the last one, but the one before it, was it 3 minus 4i?
Yeah.
Okay, so it was 3 minus 4i. And we had converted it to trig form. I remember the radius was 5. The angle was 300 something. 306.87? Okay. So I'm going to come back to that 5 cosine 306.87. I'm going to take this first, and I'm going to do something with it. Okay. I'm going to raise it to the 3rd power. What does it mean if I take this and raise it to the 3rd power? Okay, and what does it mean to cube something? Take the number, multiply it by itself 3 times. So that means this times this times this. Now, cubing it isn't really that big. Cubing is only multiplying it by itself 3 times. But imagine everything I'm doing if this number was like 300. Okay? So the method I'm doing right now wouldn't be practical. But 3 is small enough that I can do it. Right, so let's cube it and see what we get. So we got to multiply this out. 3 times 3 is going to give me how much? 9. I'm going to get negative 12i and another negative 12i. Negative 24i. And then what about negative 4 times negative 4? That gives me 16i squared. So that's the first 2. I didn't do anything with the last 3 minus 4i yet. That's going to be at the end. Let's combine like terms. What's 16i squared? Negative 16. So my like terms are 9 minus 16. That's negative 7. Okay, so I get negative 7 minus 24i, and now we got to do it again. Because we're cubing it, that's the last time. But again, imagine this to like the 300th power. You got way too many multiplications. You couldn't do that. So you got to come up with something better, which is what we're going to look at. All right, let's do this out. What's negative 7 times 3? And then we get negative 7 times negative 4. 28i. And what's negative 24 times 3? So that's negative 72. And 28 minus 72 is going to give me negative 44. Okay, so negative 44i. And then the last part, negative times the negative is going to give me positive. What's 24 times 4? 96 I squared. But 96I squared is really what number? Negative 96. Just put that in parentheses because that's what it is. Okay, like terms, negative 21 and negative 96. That's negative 117. Now, hopefully I didn't make any mistakes. I don't know. But in theory, if you cube what we had, that's what you should get. Negative 117 minus 44i. Any question on that? Right. Now, I want to take that and put it in trig form. Because what I'm going to show you today is going to give you an answer to this exact same problem 10 times as fast as we just did it. But the answer you're going to get is going to be in trig form. So to compare it to this answer, we need it to be the same. Okay. So negative, 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 negative. What quadrant is that? 3. So the angle. What's your formula to find theta in the third quadrant?
180 plus inverse tangent of y over x.
Good. 180 plus inverse tangent. Since they're both negative, they're going to cancel out. So 44 over 117. Okay, let's see what we get for an angle. Plus inverse tangent of 44 over 117. 200.61. That's my angle. 200.61. Okay, and my radius. What's the first number that I'm going to square to find my radius? So negative 117. What's the second number? Negative. Yeah, if we're going to say negatives, then let's just stick with all negatives, even though the negative goes away when you square it. And to get r by itself, how am I going to get rid of that exponent of 2? Square root. So negative 117 squared. See, watch how long this is taking. This is not quick. Right? There's a better way to do this. Plus negative 44 squared. And because I have a negative, I should put those in parentheses like I wrote it on the board. So negative 44 squared. Oh, I've messed this up. Second answer. Okay, well, that's good. And then negative 117. Let's see if I can fix that. Or make it worse. Oh, the negative doesn't need to be there. It's going to cancel out anyway. We get a nice radius, 120. Okay. So if you were to take this number, 3 minus 4i, and cube it, that's what you get, negative 117 minus 44i. And this is what you get when you write it in polar, or trig form. You get an angle of 200.61, and you get a radius of 125. Okay, any question on what we did there? To the what? So let's learn a better way to cube the number 3 minus 4i. And it's going to involve not using the 3 minus 4i, but it's going to use the trig form instead. And that formula that we're going to learn to take a number and raise it to a power is called de Moivre's theorem. It's one of the 3 things we're going to look at today: raising to a power, multiplying, and dividing. You can do them in any order. They don't build on each other. They're all pretty simple. So this is a trick to raise a complex number to a power. But the catch is the number that you're using has to be in trig form or polar form. Okay, so let's say we had a complex number and we want to raise it to the nth power. If you want to do it without this formula, you've got to do everything I just did. A lot of foiling, combining like terms, it's going to take a while. If your number is in trig form, all you have to do is take the radius, raise it to the power, take the angle, and multiply it by the power. Those two calculations take the place of everything that we did on this page right here. I'm going to be able to take all that work and I'm going to shorten it up to one line. All of that. But your number has to be in trig form. That's why I wanted to use one from the homework that we've already changed to trig form, so we don't have to do that part again. Okay, but just remember the two things. Take your radius, raise it to the power. Take your angle, multiply it by the power. Let's go back to the problem we just did, and let's do it this way, and you're going to see how much quicker it is. In fact, I can fit the whole thing right there in that box. So the formula said take your radius and raise it to the power. What's the radius in the point that I'm going to use? Well, this is what we're going to compare our final answer to when we're done. So this is the final answer, doing it the old way, the slow way. Now we're going to see, can we get this same answer doing it using de Moivre's theorem that we just showed you. So yeah, what's my radius of my original problem? Nope, that's my x value. 5. So take your radius, and what's the power that we're using? 3. We want to try to cube this. We're not doing it by writing it out 3 times though. Okay, that's the slow way. So you take your radius, raise it to the power. Now, you take your angle, which is 306.87, and what are we supposed to do with 306.87? Multiply by the power. So 306.87, that's the new angle, 920.61. That calculation that we just did, raising this to the 3rd power and multiplying this angle by 3, just took the place of all of that. Let's simplify it and see what we get. What's 5 cubed? $125. Now, what did we get for a radius when we did it the slow way? Jackson? I did. What did we get for the radius?
For the radius of 125.
We got 125. What did I just get for the radius when I took 5 and cubed it?
125.
125. I just got the same radius a lot faster. All I had to do was cube the 5. And now, what did we get for an angle using the trick I just showed you? 920.61. Is that the same as the angle I just got right there?
No. 700.
Okay. Well, that's not good then, because that means what I just showed you didn't give you the same answer. Or does it still give you the same answer? 920.61 is a pretty big angle.
Yeah, but you're not giving the answer because if it's 720 degrees more.
So what can you subtract to make that smaller?
720.
Yeah, you could subtract 360, and then you'd have to subtract 360 again, because subtracting 360 just takes an angle and makes it smaller. And you get 200.61. That's exactly the angle we got right here. And all we had to do to get those two numbers, we didn't have to write down 3 sets of things and FOIL them all together. We just had to multiply the angle by a number and raise the radius to a power. And it's a lot faster way to get the same answer. What was it? 306.8? 200.61. 200.61. So what's in that box is getting rid of everything I just wrote on the board right now. Now, you might say, well, it's only cubing it, right? You could just cube it. You could do it this way if you really wanted to. But what if I gave you this? 3 minus 4i to the 56,000th power. You're not going to write out 56,000 sets of parentheses and try to FOIL it. That's not going to work. But if I wanted to do this problem, I can do it just as fast as the one above it. This exponent doesn't make a difference. All I got to do is raise 5 to this huge number, and then multiply this angle by that number, and I'm done. Now, if your radius is going to end up being a really big number, like if you actually did 5 to the 56,000th power, that's going to be huge. You probably can't even write that down. The calculator's not even going to do it. You just leave it as 5 to the 56,000th power. You don't have to do that out. So when would you not do it out? I don't know. It starts to be in like the millions. That's probably too big. Yeah.
So how will we know when it's like to subtract by like 720 like angle?
What's that?
How will we know to subtract the 920 by like 720?
Oh, they're always going to ask you for an angle between 0 and 360. So if the angle is over 360, you need to make it smaller. If it comes out under 360, you need to make it bigger.
How do you know how much bigger you're going to need to make it?
Like how many times to add 360?
Yeah.
So if I had an angle like negative 3,578, what I do is I just hit plus 360, and I say, no, it's still negative. I got to keep going until it's not negative. So just keep doing plus 360 until you get to the first positive. It doesn't matter how many times you do it. We don't care about that. All we care about is that really is the angle 22 degrees.
Okay.
So if you multiply your original angle by a big enough number, you may have to add or subtract 360 a lot of times. Like there, I might have just done it 7 or 8 times. Let's try another one of those. But I'm not going to FOIL it out. Let's try this one. So this is raising something to the 8th power. If even 8, that's kind of bad if you had to do that the old way. You're going to have to write your complex number down 8 times. And then you'd have to FOIL everything together. There's just too many things you could do wrong with that. Right? And even time. You're not going to have enough time to FOIL something 8 times. So they've taken the complex number and they've changed it to trig form. And now we can raise that to the 8th power very quickly. What is my radius in the original problem? Oh, tell me. What's my radius? 3. And what power are we going to raise the 3 to get my new radius? 8. 3 to the 8th, that's not a huge number, so we're going to do that out. All right. Gavin, what's the angle in my original problem?
For which one? Cosine or sine?
Be the same.
Oh, 20.
Yeah. And what are we going to multiply that angle by?
3.
So we don't multiply the angle by the radius. We multiply the angle by the what? The exponent. What's the exponent here?
So 8.
8. So you multiply the angle by 8. What do you get when you multiply 20 times 8?
160.
160. Since that did not go over 360, I don't have to worry about adding or subtracting 360. 160, that's fine. Plus I sine 160. Okay, so now we want to do out 3 to the 8th. I don't think that's that big. 6,561. Yeah, definitely small enough. We can do that. So 65, 61 cosine 160 plus I sine 160. Any question on that? Check one more with that theorem. Let's take 2 plus 3i and raise it to the 6th power. Is that one set up and ready to use the shortcut that I just showed you? No. What's wrong with it?
Got your imaginary number on the outside.
Yep.
It has no angle.
It has no angle, which means it's not in what form?
Trigonometric form.
Yeah, it's not in trig form. This is standard form. So if somebody wants, go ahead and write 2 plus 3i 6 times with 6 sets of parentheses. You start doing that, and we'll be done before you finish. Okay, so we got to change this to trig form to make this faster to do. Don't write it out 6 times and start 4. All right, so Brady said one thing we need there is we need the angle. And what else did you say we need?
It's a polar form.
And what's the other thing you need besides the angle?
Imaginary number.
The radius. Okay, we need the radius and the angle. Okay, so we've gone right 2, up 3. Let's start with the radius. You don't have to give me a decimal. Let's leave it as a square root. What's going to be the length of the radius in that one?
Square root 13.
Square root of 9 plus 4. So the radius is square root 13. And my formula to find the angle for the quadrant that I'm in. What is it again? Inverse tangent. Inverse tangent. 3 over 2. Okay, so inverse tangent, 3 over 2. So we got an angle of 56.31. Okay, so what's that going to look like when I write 2 plus 3i in trig form? What's the whole thing going to look like?
2 times cosine.
Well, remember, these numbers are gone now, right? Because we rewrote it as a radius and an angle instead of an x and a y. So this whole thing is gone. Square root of 13, yep. Well, parenthesis.
Cosine times 56.
What's my angle? 56.31. Okay.
I sine.
I sine 56.31. And what power are we raising this entire thing to? Sixth. Now, this part is the easy part, once we get it in trig form. How do we get the radius in the final answer? Square root 13 to the power of 6. So we're going to need a calculator for that. So square root 13 to the power of 6. You need to make sure the power is on the outside. All right, comes out next, 2197. Cosine. And how am I going to get my angle? Multiply what by 6? 56.31, and that's definitely going to be under 360, so we're not going to have to fix anything. 337.86. Hey, had you tried writing this out with 6 sets of parentheses and foiling it all together, you'd still be going. Right? And we're done. And look at all the work we had to do. It's not that much work. Okay, so that's how you can raise a complex number to a power. And that's probably the hardest one that we do today. Is there any questions on how to use de Moivre's theorem? Okay. Let's look at this. So raising to a power, that's de Moivre's theorem. Okay, we're done raising to a power. Next thing we're going to look at is multiplying. What if you want to multiply two complex numbers together? Well, if the two complex numbers were in standard form, you'd have to do something like this. Just make up some different numbers. Okay. If I wanted to multiply these in trig form, I'd be done right now. I could look at it and tell you the answer. But to multiply these in standard form, I don't know what it is. I still got to do it all out. I can still do it pretty quick. We get 12 minus 20i plus 8i. And then 2i times negative 5 is negative 10 I squared. So that's 12. Negative 20 plus 8 is negative 12. And I squared is negative 1. So that becomes plus 10. And 12 plus 10 is 22. So it's not awful to do it. You can probably do that in about 30 seconds. In trig form, I can do it in about 5 seconds. It's a lot faster. So what do? Well, you're going to have two complex numbers. The first complex number is going to have a radius, and we'll call it R1. The second complex number has a radius, it's R2. The first complex number has an angle, I'm calling it theta 1, and the second complex number has an angle called theta 2. Instead of multiplying, combining like terms, changing to I squared, and then combining like terms again, I don't know how many calculations that is, probably 8 or 9, we can do it in 2. All you have to do is take R1 and R2 and multiply them together. That's going to be your new radius. Take theta 1 and theta 2 and add them together. That's going to be your new end. So those two calculations are going to replace everything I just did. Multiply the two radii together. Add the two angles together. And you're done. There's going to be any foiling, I squareds, combining like terms, none of that is going to happen. See, I can look at that. I already know the answer to that problem. Because you don't have to FOIL anything. So it says to multiply them together. What does it say to do with the two radii from the original problems, Z and W? Multiply. What are my two radii? Well, what are my two radii first? 3 and 5, and when you multiply them, you get 15. So there's your radius that you have done. And what does it say to do with the two original angles? Add them. What do you get when you add those up? 120. You're done. That's the final answer. It's way faster to multiply these two together in trig form than it would be to do all of that stuff. Any question on that one? I think I got one more with Z times. We'll do one more with Z times W, and then we'll do Z divided by W. Well, if you can do Z times W, you can probably guess what the formula is for Z divided by W. It's almost the same thing. Okay, so here's Z. Here's W. What they call them, that doesn't matter. They could call them Z1 and Z2. They could call them A and B. It says, here's your first one, here's your second one. Multiply them together. What's going to be the radius when we multiply these two together? 5. Yep. Cosine. And what's going to be the angle when we multiply those together? 345. Okay, what would you get if you left it as a negative?
Negative 15.
Right. When you add these together, you get negative 15. Now, directions didn't say to make it positive, but I've told you you probably should for the test. So if you get negative 15, add 360, and you get 345. That's it. So that's how you multiply two complex numbers that are in trig form or polar. Any question on this one? So that's multiply. Let's look at divide. I'm going to use the same kind of setup. You've got two complex numbers. Each one has their own radius and their own angle. And we want the formula for dividing. Well, if you know what you do with R1 and R2 in the last formula, probably going to have an idea what you do with R1 and R2 in this one. What do you think you would do with R1 and R2? You would divide them. So it's going to be R1 divided by R2. And when you multiply, you add your angles together. How do you think you're going to get your angle when you divide? You're going to subtract. And this formula takes the place of having to do something like this. Let's say I had 3 plus 5i, and I wanted to divide by 2 plus 4i. Without that formula, if I want to do this, I need to multiply top and bottom by the conjugate. Now you're going to do all that out. Right, the bottom's going to come out to 20, so we can use a trick for that. 2 squared plus 4 squared. But we still got to FOIL everything in the top. We got to deal with the I squared, combine like terms, and split it into real and imaginary. This is going to take the place of all that. So here's my two complex numbers. Make it a little easier to see. 3 cosine 75 plus I sine 75. And 5 cosine 30 plus I sine 30. And they want us to divide. Okay. What's your radius going to be when you divide z by w? 3 over 5. We just leave it as 3 over 5. Over 5. And what's your angle going to be? 45. 45. 75 minus 30. That's our answer. Any question on how we got the 3/5 or the 45? Okay, I think I got one more of those. Okay, so z divided by w again. Z is 10 cosine 20 plus I sine 20. And w is 1/2 cosine 100 plus I sine 100. What's my radius going to be when I divide z by w here? 20. Sometimes people say 5. If you're thinking 5, you're thinking 10 divided by 2. This is 10 divided by 1/2. That's different. So 10 divided by 1/2 gives me 20. 20 cosine. And without doing anything extra to the angle, what do you get for the angle here? Just following the formula I gave you. You get -80. Now, if the directions said to make it positive, what would you add to it? You'd add 360. And if you take -80, you add 360, you get 280. So we're going to write 280. So that's your answer in trig form or polar form. Same thing. What if they said to you to take this answer and put it in standard form?
Then would you not just write it back out how it was?
How would you take this and put it in? Because we never had this how it was before. This is something we made.
Or would it just multiply the 20 back into anything?
Yeah. We just multiply the 20 times the cosine of 280. Okay, and that's going to give me something. 3.47. And then we're going to multiply the 20 times the sine 280. 20 sine 280. So that gives me negative, so it's going to be a minus 19 point, it's about minus 19.7. Yeah, and you have to put the I. So this is standard form. That's trig form. It's not very hard to change it to standard form once you have trig form. It's just the distributive property. Well, how would you know if you have to do this? The directions would say on the test. Either leave your answer in polar form or leave your answer in standard form. It'll tell you. Any questions on that? So those are the three things that we do with polar form. Multiply, divide, and raise to a power. Okay. So So on page 333, the homework is 33 to 37 odd, and 41 and 42. For 41 and 42, they say something in the book, I think, about changing it. You can just leave the answer, 41 and 42, in polar. So you don't have to change it. And let me pause and I'll put up a list of topics that are on the test.